Hello and welcome to this brief walkthrough of the curriculum I've created to bring business and data analytics to everyone. High performance machine learning with no code and low math to solve real problems. All business majors at the University of Illinois Urbana-Champaign had to take my course, and those few who went on to pursue data science were accepted at top universities for graduate studies. Technical University of Munich, MIT, Stanford, but that was only 5% of my students. That left 95% wanting the ability to execute high performance data mining, but lacking the desire to become full time data scientists. Now, to reach that 95%, and in fact to democratize machine learning, I followed the development of various technology platforms for over 3 years. And when the conditions could satisfy my first principles for citizen data science, I formed a company, applied and won a trademark, and over the course of a year and a half plus, wrote the book that redefines machine learning for the rest of us. But that's not why you should be listening to me. Together with one of my undergraduate students, we discovered that the rules used for selecting feature scaling were exactly wrong and have been so for at least the last 30 and perhaps 50 years. The reason why is an advancement of the theory of bias and variance in an important, new, and as yet unexplored direction. This work has been seen by over 10,000 data scientists. We've received upwards of 600 accolades spanning every major industry and many key players. And in the course of it, I also created the feature scaling ensemble, which when paired with logistic regression, turns it into a multinomial classification powerhouse. But enough about me. Let's talk about data science. Data science is broken. And I ask myself, what are we doing wrong? I'm sure that individually material is being taught that is irrelevant, obsolete, or factually wrong. I know, I've done it. But in general, it's not what we're doing wrong, but instead what is missing. And we propose an entirely new role in data science, one that can act as a force multiplier for technical data scientists and perhaps restore their passion for what can be a truly great career. In 2016, an article appeared in Forbes magazine written by technology writer Bernard Marr, and in it he cites Gartner Group as having coined the term citizen data scientist. Now, they've left that definition very loose, as you can understand, because truly, until now, citizen data science has been relegated to using raw data visualizations, whether it is pivot tables in Excel or Tableau or Power BI. It's raw data visualization because machine learning has been outside the realm of the citizen data scientist until now. What has been missing is the simplification of machine learning with a minimal sacrifice in performance. Now, these are the pain points that led to the creation of a philosophy, one that establishes first principles for the role of analytic citizen data scientist. But in effect, we are pushing high performance machine learning to the edges of the organization, where the data lives. This is strategic and this will be profound. It may not be as profound as when we pushed desktop computing to the edges of organizations back in the 1990s, but it will be profound nonetheless. Welcome to Analytic Citizen Data Science, where we teach the fuzzy instead of the techie. And instead of teaching someone how to design, engineer, and drive a good car, we're going to hand them the keys to a very fast car and teach them to drive very fast. Now, these rules were developed with business analytics in mind. Keep it simple, clear, and economically supported. But even so, the all or nothing represents the only moment of satisficing in this entire process. Because in part, the dual experiment is so over the top, it exceeds by much more than almost every data scientist would attempt on a single problem. We are not guilty of oversimplification. Instead of 18 weeks of Python, we spend an afternoon covering the three essential components of all machine learning: variables, calculations, and loops. You build those in software, you know how they work in software, you can imagine anything on top of it. But lest you think we're being naive, if you have two companies selling the same product for the same price in the same markets using the same supply chains. And one uses managerial intuition and raw data visualization, and the other is analytic driven. The analytic company will possess a competitive advantage. And when you understand what that is and why, you will truly understand the power of business analytics. It's not so much on cost savings as it is on stability. Why exploratory data analysis? Well, once again, we have to strip the process down to its clear decision points. The first decision point is missing values. And the fact is, we have the best imputation algorithm. We're using extra trees. If you're using extra trees in Miss Forest, you are doing it very well. If you're not, you could be doing it better. Anomalous samples, outliers. Well, we have the isolation forest algorithm. It's what I use in my research to treat outliers. It's a very good algorithm. It's a very good all-around algorithm. And if you aren't using isolation forest, you might be able to do it better. But what is the most important thing that a technical data scientist does with exploratory data analysis that yields the most benefit? Individual treatment of the predictors with respect to the outcome. What happens if we don't do that? Well, I put that to the test. I was able to squeeze an extra 0.5% of classification error out of the model, and I was able to squeeze an extra 1.5% of regression error out of the model, and that was it. This is what satisficing looks like. Herbert Simon coined that term in 1957, and here it's still with us today. This is what it looks like. But we don't go light on data understanding. We still go through the basic commands, but we go through it like we're teaching fuzzies, not techies. We explore the humanity behind the data. What's the psychology behind this? What's the behaviors behind this? It relates much better to the fuzzy. They get an idea that there are humans behind a lot of this data, and humans make decisions behind a lot of this data, and they learn much more about their own humanity as a result of it. Well, here is the full process data preparation. And with this slide, I'm providing a few gifts. Your students can learn the full data preparation stack in a single semester. And you are now free of the pedagogical prison that's built out of code and math, the concrete and steel of our confinement. Instead of teaching the code and the math behind what is thousands of lines of code here, you teach stories. Why do we turn it on? Why do we turn it off? And what are the fiddly bits to set it up? That's it. It's metaphor, it's narrative, it's storytelling. If you want to increase diversity in analytics, my hypothesis is that you will gain far greater ground with storytelling than with more code and more math. And we can stop trying to convert our fuzzies into techies. They get to stay fuzzies, and your course becomes yours, uniquely yours, because they are your stories. And they are the stories you craft to meet the needs of your audiences. Oh, this also has one more gift. This is the birth of template-driven analytics. Now, this is my basic template for tree models. I have another basic template for linear and distance models, but are there templates for job roles, for industry types? Are there templates for other data types? I don't know. I haven't looked into it. This is an open field of research. Now, when we run this command with a classification experiment, we run all of these models and identify the top performer for each metric. And when it's regression, we run all of these models. See, it's always been about which metric says which one is best, but I was certainly seduced by the algorithms. I love algorithms. I love the math. I love the mechanics. But the fact of the matter is, they blinded me for what was truly important. And what is truly important is what metric am I using to select the optimal model. And you thought that the introductory class on machine learning wouldn't include Bayesian hyperparameter tuning with plots to show the impact of iterations on various metrics? Yeah, we got you covered. These are the tea leaves by which the citizen data scientist understands model fit and model performance. Now, interpreting many of these is conceptual, or the least using very simple math. Now, for example, in the upper left-hand corner is the t-SNE manifold plot. And that shows us that linear models are never going to work well with this data. And just below it, the training curve shows us that when our model sees 20 samples per predictor on the training data, the variance collapses on the holdout data. So it's 20 samples, not 10 per predictor, to make a sound business decision. But in spite of that, in spite of all of these mechanisms for understanding model fit and performance, there is still a question that is not answered. How do we know that we have the right model? Now, here's an actual compare models output for the IBM employee attrition data set. The yellow shading indicates the best performing model for each major metric, and we can see that the CatBoost classifier was best in accuracy and precision. So very good for the CatBoost classifier. Now, most books still teach accuracy as the go-to metric for business analytics, when in fact, it's much better suited to data analytics. And there is a difference between these two fields, as I shall soon show you. Using data from the U.S. Department of Labor and the Human Resource Managers Association, the economic picture for employee attrition shows an inconsistent loss of up to $685,000 per managerial experience and intuition and raw data visualization. Now, it can be much better than this. Don't discount managerial experience, but it will fluctuate. Now, using our accuracy-focused CatBoost classifier, we've improved this loss to a much more consistent $400,000 in the red. And you'll notice I put a box around true negatives because most, if not all, books show true negatives as having no value, but I can show you how to identify the value if it does exist and how to calculate it. In this case, it's fairly substantial. But now we're still back to, okay, this is the best we can do with accuracy. Is that still the best model? With our new platform, we now have a new way to determine model selection through an economic analysis of the metrics. So if the cost of a false negative is much greater than a false positive, you want to look for a model optimized for recall. If the situation is reversed, where false positives are much greater in cost than a false negative, you want to look for the model optimized on precision. If the false errors are nearly equal and there's no value or low value to true negatives, then F1 score is good. And here, look at that. Only if all four quadrants are equal in cost, sort on accuracy. So accuracy is for data analytics. It rarely meets a condition with business analytics. So now in the case of our data, the cost of a false negative is about 7 to 10 times greater than the cost of a false positive. That's for the IBM employee attrition data. So which model was best on recall? It's the naive Bayes model. Highest on recall score, one of the worst in accuracy. But let's go find out how that works under an economic application. We built a naive Bayes model using this command. It generates in less than 2 seconds, which creates this confusion matrix and gives us this economic model. Data analytics, focused on accuracy, gives us this advantage. But business analytics with no code and only dollars and cents math gives us this much more. It's always been about the metric, and we never could see that until now. Yes, and even at this introductory level, we have fairness and human bias checks through prediction analysis. Now, in this case, we're comparing male gender with female gender. I know that's biological sex in IBM terms. And we can see that there's no difference in prediction between these two. So our model is not biased with regard to IBM's gender classification. But we can check other things using fairness and human bias. And throughout my book, I put in a few satirical jump points. I am an award-winning satirist, and I put in what may appear to be some caustic statements about business. But these are there for a reason. They are there to provide a jumping-off point into business ethics. I believe it is critical that every course taught in a college of business has a modicum of business ethics ingrained into it, because I have operated at the executive level in multiple high-tech companies, and I can shock you with what I've seen. Teaching students how to maintain their honor and integrity when a lot of people around them are not doing the same is an important lesson to learn in college. In just a single semester, students can gain predictive and interpretable modeling skills on par with technical data scientists, and they do it with no code and low math. And this is open to everyone. Think about the entire campus. Think about psychology, sociology, geology, linguistics, history. There are many fields that would benefit from a knowledge of machine learning, and yet They don't have the exposure to it, nor should they. No code, low math is the way to go to reach them as well. And it can be a competitive advantage. The first few citizen data scientists, I believe, will command a wage premium in the marketplace, the same way that the first few students who understood analytics commanded a wage premium in the marketplace. And at the same time, we're all working to improve data science. Thank you so much for your attention. If you have any questions, send me an email, dave@citizenanalytics.net or raccoon@citizenanalytics.net. I'll post a number of links down in the comments so that you can follow links to my research. It's all published under Creative Commons. There's no paywalls, and other information that you may find beneficial. Thank you so much.